today's training program, and I congratulate Dr. Rifat, who has been able to get this training program under MSME so that it can benefit our students, entrepreneurs, and to the larger section of the students. So as my topic is that how pruning can be used as a tool to start the climate resilient apple production. So as we see that how a pruning can become a tool, otherwise pruning is simply when you cut a tree, and you can have different types of cuts that you have already understood and you have already been taught about the different cuts. So that means with those 4 cuts, whether that is thinning, whether that is heading, whether that is dash cut or the stub cut, are these cuts able to develop the climate resilience in the apple production? So what actually we understand by climate resilience is that we have the vagaries of weather changes. Like we can have extreme of heat, we can have extreme of drought conditions. So in those conditions, how a pruning can become a tool to withstand all those vagaries?
You have to just tap it, like
only that?
Yeah. आप फ्रंट पे जाओ एंड उसको अपवर्ड की तरह टैप करके अपवर्ड की तरह ले जाओ.
यस जरा
स्क्रीन पर.
अच्छा है तो टच स्क्रीन.
In upward direction.
Upward direction.
In the middle of the slide.
Yes.
No. जहाँ पे आपका होगा. Yes.
So when we talk about the resilience, so what we actually want to, okay,
एक मिनट इसको zoom करेंगे. एक मिनट.
इसको ऊपर. हाँ जो छोटा कर.
सिलेक्ट करके उसको टाइटल को ऊपर ले जाओ.
हाँ इसको ऊपर ले. आप जरा ऊपर जाना. एक
मतलब यहाँ पर आप बैठो या क्यों नहीं?
एक आप सिलेक्टेड ही कर रहे हो ना रिकॉर्ड कि नहीं? ये कंटिन्यू रिकॉर्ड
नहीं, अभी इसमें काट आएगा. इसमें काट आएगा क्योंकि इसमें पॉज आया ना. आप आराम से दे दो, इसको काट करेंगे खुद ही जहाँ पे ये intervention हमारा.
So now when you talk about the climate resilience and when you talk about the production of apple under those circumstances, so we have a kind of volatile climate where we can understand that now we don't want a perfect tree for only when we talk about the yield, but we want a tree that has a stability. That means that can withstand when it is too hot, when there is a drought, or when there is other extreme weather vagaries. It should stand that and it should become stable. Not only the perspective is not only the yield. So what is climate smart pruning then? So the strategic manipulation of tree software. What actually is within the tree that is being influenced by the pruning, these are called the hormones. We call that tree software. And then what we are actually trying to manipulate the hardware, that is the vascular and the physical structure of the tree to mitigate the risk of heat, drought or the extreme weather. So what are the objectives of climate resilient pruning? And what is it different, how it is different from the traditional pruning? As I already discussed in the previous slide, that the climate resilient pruning, that means you want a stability in the yield, and when you talk about the traditional pruning, it was more emphasis was on increasing the production. So when there is an object, then what is the objective of climate resilient pruning? That is, we want to develop a canopy that can regulate the thermal regulation. That means when there is extreme heat, how we have to develop our canopy that can shade the trunk and the fruit. That is number one objective. The second objective is that when we talk about the resilience, that means that we have adversity, like we can have a heavy snow, we can have high winds. So in those conditions, how we can structurally build the tree in terms of we have certain things in the tree that we can engineer, that is the branch angles. Just by the manipulation of the branch angles, we can develop our tree that can withstand heavy snow and heavy high winds. Then these are the two objectives. The third objective is, when in case of drought, if we have a drought condition, then with the help of pruning, we have to increase the hydraulic efficiency. What does that mean? That means we have when you are cutting the tree, when you are pruning the tree, that means you are reducing the leaf area, and leaf is the source which pulls the water from the root towards the upside, and that means the more number of leaves, the more uptake of the water and more influenced by the drought. So what we can do, that if we can balance this leaf area with the root capacity, that means we are able to develop a kind of tree that has a resilience to the drought. Then the fourth one is that we have lots of pathogens are there, lots of diseases are there. So how, by the way of this pruning, how we can mitigate and optimize this pathogen population, which can lead to the disease outbreak, the severity of the disease. That means we have a pruning that can optimize the airflow. So the kind of pruning that will help us in increasing the airflow within the tree, which will reduce the wetness of the leaf, and that will indirectly reduce the pathogen, the severity of the pathogen. So the objectives of climate smart pruning is, number one is the thermal regulation, then we have the structural biomechanics, then hydraulic efficiency, and then pathogen mitigation. Now all these factors and all these objectives, how we can achieve through the pruning, that we will be discussing. So then module number 1, we have the challenge number 1, that is, when I am talking about the temperature goes beyond 35 degrees centigrade, that means I can face two things. That is, my fruit can burn. The other thing is there will be a bark necrosis. Now, I have with me, I have the skill that I need to develop a kind of dappled light matrix management. I will be explaining this. And then, what is the technique with me that I can achieve that objective? That is, that the thermal, I have to introduce that I have to regulate the thermal regulation. So the technique is that from the open center, I have to move to the tall spindle, and I will be telling you that why. And the physiology is that I will be utilizing the thinning cuts to create a 3D leaf shield. This will ensure that I will have a scattered radiation for color development and for anthocyanin without a direct thermal load that cools the tissue. Now here, my matrix, that means my objective here should be around 60 to 70% light interception. Now the crux of this whole slide is that, before I come to the slide, I would like to ask you that, do you know how the sun scar happens on the fruit? There's a reason. The reason is, okay, before I talk about the sun scar, I would like to talk about the 3D leaf shield. So this 3D leaf shield, what does that mean? Earlier in the slide, I talked about the dappled light intensity means when you look at the floor, the sunlight is falling, and if you find several spots of light and several spots of grey, that is the shade, mix of light spots and the grey spots, that means you are filtering the light and you are achieving an optimum objective, that is your shielding. You are having a nice shade. So this 3D leaf shield is what they are actually around the fruit. You are creating a 3D dimension of leaf. That is, when you are cutting, when you are having a thinning cut, you are removing a whole branch from its origin rather than heading cut, which is just cutting the tip. Now what this thinning cut will do, it will create windows in the canopy. As you all know, when you are removing the branch, you are increasing the canopy, you are improving the infiltration. Then what will happen, you are creating the window and air can move through to cool the fruit, and the remaining branches, which are the remaining, that will overlap enough to create a 3D matrix. So this is how you are able to produce a 3D leaf shield. When you are removing few branches and keeping few branches around that fruit, you are helping it to cool down. Then we have a rule when you are developing this 3D shield, you have a rule that is called 15-minute rule. In that, it means when you have a well-pruned, climate-resilient tree, a single fruit cluster should only be in direct contact with the intense light for only 15 minutes, and after that, when the sun is moving, then immediately there should be a neighboring leaf that will provide the shade again. That means you need to have a balance between the leaf and the fruit. That is the crux of this 3D leaf shade. This is how we are trying to build a climate resilient tree where we are mitigating the heat stress. Now, coming back to again, I talked about the sun scar and the bark necrosis. So you'll be surprised to see that when I'm talking about the sun scar, why our fruit burns with the intensity of the sun? The reason is that when you look at the fruit, when the sun gives its light, it gives in the form of short wave radiations. And inside that fruit, you have 80% is water. We have a water sip here actually. And what it does, the fruit, it tries to trap the energy of the sun. And apart from fixing that energy, it also absorbs the infrared radiations. And those infrared radiations converts to the thermal energy. And our fruit starts to build up the heat. Then what happens later? Now the same light is falling on the leaf also, then why doesn't our leaf also burn? The reason is that the leaf is very thin and it dissipates the heat immediately. And also, since it is thin, it is not dense, so it is not accumulating the heat within that sphere. So what happens? That becomes a source of heat trap. That's the reason that we have more heat trapped within the fruit as compared to the leaf. That is the number one reason. When you talk about the heat trap, here I would like to add that if your ambient temperature is 35 degrees centigrade, and you will find that on the fruit, the temperature will be 45 to 50. And this is the reason that the fruit is trapping that heat. Then what happens? Okay, both the leaf and the fruit has trapped the energy, but what is the next thing? How the leaf is still cooling itself? This is the reason because the fruit lacks the evaporative cooling. That means if you look at the leaf, there are lots of microscopic tubes which we call stomata. So it starts emitting that through transpiration and keeps the leaf cool. But fruit, it does not. It has a very less stomata, and so it cannot evaporate. It cannot cool itself. But there is another drawback with the fruit. It has a cuticle, waxy layer, that still hinders it further, that it cannot transpire. So this is the second negative point that happens with the fruit, and it starts building up the heat. And this third point is boundary layer resistance. Every object, it has a thin layer of air, a still air around it. And around the fruit also there is a still layer. And this still layer continuously traps the energy from the sun. And it heats up. And during the hot summer, it gets trapped, it gets clinged to the fruit. And once it gets clinged to the fruit, it starts heating up the fruit. First, there is a heat trap effect, then there is a lack of evaporative cooling, now there is an effect of the boundary layer resistance. If there is no wind flowing, it will not move this layer. That's why wind is very important, airflow is very important. It keeps on removing the heat layer. So it is not removing that heat layer, and the physiological consequence is, when these three things happens, then we have a sun scald, and at this temperature, what happens? Now, how this look of the fruit changes, how it turns brown, because these temperatures, what happens at this temperature when it turns 45 to 50, the proteins in the fruit skin, they denature, they lead to permanent browning or cooking of the tissue. And likewise, we have one more thing, that is the bark necrosis. If you have the open center trees, what happens to the main trunk? It is exposed. Then again, the intense UV kills the cambium, that is the living layer under the bark. Effectively, that burns the tree from the sun. So this is how the impact of the heat is on our trees. Mostly, we have the influence is on the fruit and the bark. So that was the number one objective. So I told you that to fulfill that number one objective, that we have to build a kind of canopy that can shield itself. And the canopy that we were able to build, that's the 3D leaf shield that I already discussed. Then we have the other module is that if we have a condition of drought, so when drought is there, what happens that we have a challenge. We have to somehow balance the budgeting. We have to do the budgeting. That means whatever is available now, we want to use it the best way possible. So what we are going to do, we are shifting precipitation and flash droughts leading to xylem cavitation. Now I would like to explain this xylem cavitation, what happens. You know what, when the water flows through the xylem to the canopy or to the moves through the plant, these water, they are attached to each other by cohesion. Matlab these water molecules are attached to each other by cohesion, and they form a kind of tube, and then they move through that xylem tube. Xylem is nothing. Xylem is nothing but xylem is just a structure through which these water molecules they move up to give water to the entire plant. Now what happens when you have a drought? This cavitation means that you have a drought and there's a transpiration is the rate of transpiration is very high. One water molecule is moving, it's going up, but suddenly under -15, you can say under a negative pressure, it moves comfortably. But when the pressure is more, what happens? This column breaks. Okay, the water molecules they separate from each other because of the pull, because of the drought, because they are not able to suffice the water uptake, so they break. Once they break, between the two water molecules, there is the accumulation of oxygen. Oxygen comes in, वो बीच में xylem in water molecules के बीच में आ जाता है, and that is what we call cavitation. Yeah, there is another name for this, embolism. And when this happens, it is very difficult that we can restore our plant, because embolism normal in a human also. If there is the blood gets, or if there is a oxygen molecule gets trapped, then we call that embolism. And the same thing happens in the xylem vessel. So that means what we need to do. So this is physiology that we know that every leaf is a hydraulic pump. So what we have to do? So what is our objective in that case? So if there's a drought, that means we have to reduce. What we have to reduce? The hydraulic pumps. What are those? These are the leaves. That means we have to decrease the leaf area. And the result will be that it has been seen that if there's a 15% reduction in the leaf area index, we can decrease the water demand by 20%. And that is, we can keep the water potential above the permanent wilting point. So the crux of this whole slide is we have to budget the hydraulics. That means we have to maintain the water. And how we can maintain? Because we have less water, we have drought condition, so we can maintain it by balancing the leaf area index. So this was the second objective when we want to build a kind of hydraulic budgeting that we want to do within the plant when it is facing a climate resilient feature, that is the drought. And then I was talking about that we have another problem, that is the snow and we have the intense rain. So what will happen because of the both? Our structure of the plant will, so we have to develop a kind of structure of the plant that can withstand all these vagaries. So here we can see the challenges, high velocity wind and unseasonal or any heavy snow load. And what we have the skill, that means the students who are present here, the entrepreneurs or whoever have come to understand the pruning, they need to develop this cross angle skill and tension management. That means they need to know that I will be facing the snow, my farmer will be facing the snow, that what I should advocate to him and how he should build his tree so that he can very well withstand all these vagaries. So the technique is you always have to select the U-shaped junction, which is around 60 to 90, and you have to remove the removal of the included bark. Like you don't have to count the bark. Then the physiology is what? The wide angle branches, they possess a continuous wood bridge at the union which acts as a harmonic oscillator that flexes. This is a very important point that you need to understand. That when you have U-shape, it becomes like a pendulum. It oscillates. That means if the wind flows, it oscillates. It doesn't break. But when you have a V-shape, it tends to break, as I have been able to show it here. So later I will be discussing, I will not discuss the Dutch cut here. I will be discussing later. But here, from this slide, the takeaway from this slide is that you have to develop a plant that is structurally strong, that is strong, resilient, because you are able to develop the crotch angles. Yes, this is now the module 4 will describe about the pathogen firewall or microclimate control. So here, as you all know, that the challenge is when we have a warm, humid, we have flash rains, events like that drive the fire blight or the scab outbreak. This is a challenge, right? So this is the climate, this is due to the change in the climate, we can have this challenge. Then what we have? The only skill that we have, apart from the chemical and other things, we need to understand what is ventilation and the pathing. How this will help in combating that challenge. So the technique is that we have to create a kind of chimneys or use the sacrificial stuff. So I will be explaining this sacrificial stuff just immediately after this. So the physiology is that again we are trying to reduce the leaf wetterness duration, because whenever there is a humid climate within the plant, you are inviting the diseases. So the more the airflow, the more the leaf is dry, and the more you are able to control the diseases. So the biobarrier that we want to keep, that is, we need to leave a 10 to 15 centimeter stub, and that traps the bacteria in the dying wood and prevent it from reaching the main trunk vascular highway. I have a photo for this, I will show you that. So these two cuts, because you have already studied a lot about these two cuts, Dutch cut and the stuff cut. I am discussing these two cuts because of the reason that these are the two cuts that I will be using for developing a climate resilient plant. So जैसे अभी till now you will have understood that Dutch cut, how it is to be given, and the stub cut. Since I told you that when I am leaving a stub is always up to around, it is more than what we leave in the Dutch cut, that's around 1 to 2 centimeter, and in this stub cut we are leaving it at up to 4 to 5 centimeter. The reason being, if a part of it gets infected, so it will not reach the main tree. We are protecting it with the stub cut. अभी तक आप लोगों ने stub and Dutch cut you have maybe studied throughout your this course, throughout your this training program. This stub, it tries to become a firewall, and it protects your plant from immediate attack of the disease. Whereas when we are talking about the Dutch cut, we are renewing it and we are maintaining the water efficiency, because whenever we are giving a Dutch cut, which is a very famous cut in the this tall spindle, we are renewing the new wood, we are removing the old wood, and when there is an old wood, it takes up lots of water. Because the need of a small branch is less as compared to the bigger branch. So we are we are trying to maintain the branches horizontal and calm so that the vigor is less. See, again I am trying to tell you that you have to, I think I have, wait, I want to see, yes. Wait, I want to see something that maybe I missed that. Okay, yes, I have that. Okay, now, can you be, since you have done this training, will you be able to give the Dutch cut and the stub cut? Stub cut is easy, 3 to 5 centimeter. Will you be able to give the Dutch cut?
Yes, yes.
Well, how?
Where?
Yes, anybody.
Slanting कर देना.
जैसे आपका ये है ब्रांच, ये आपका या इस पे दीजिए Dutch cut.
ऐसे ऊपर की तरफ कम जगह और नीचे की तरफ ज्यादा, ताकि जो नीचे वाला बड़ हो वो उसका एंगल भी ठीक हो.
आप ठीक, गुड, ठीक. हाँ.
उसका एंगल भी ठीक हो और वो वीक आए.
तो दैट मींस ऊपर हमारा कुछ नहीं रहता है.
ऊपर थोड़ा बहुत रहता है.
व्हाट इज दैट? नीचे जो रखते हो आप, व्हाट इज दैट? स्टब में क्या रखते हैं, इसमें क्या रखते हैं? डच कट में we keep the branch collar intact. Okay, but here when you are giving the stub cut, you are leaving a piece of wood also there. and जो branch collar है दोनों में है, and that branch collar has got a specialized cells that I will be discussing. See, the purpose of keeping the dust and this stub cut again, I wanted to tell you something about those two cuts. I know that you have already studied a lot about those cuts, but I wanted to tell you about that. When you talk about this dust cut, it means you want to have a younger wood that's more efficient, because the younger it is, the more efficient xylem it has. And the strategy is, the renewal cycle, the strategy is that you need to renew the 15 to 20% canopy wood annually. And the benefit is that your orchard will have more younger wood as compared to the old clogged hardwood. So the more you have the younger wood, the more your tree will be efficient and more it will be desired. So these are some of the common mistakes that you will be, you will encounter in your field, and these are the diagnostic audits also. We have a flush cutting. What is flush cutting? When you are removing the branch collar also. Flush cutting is when you are removing the branch collar also. That means you have not left the latent bud, you are halting the renewal cycle. That means no branch will come out. That is the reason flush cut is the most dangerous cut. Then line staling. Line staling is, have you seen that at the end of a long branches the fruits are hanging?
Flush cut में हम कुछ रखते हैं या सीधा उसके
No, flush cut means you are removing the branch collar also. It goes directly. यही, these are the
prune हो जाती है फिर कैंकर के लिए.
Exactly, yes. I will tell you. I have these. I will be discussing in detail all the 4 cuts. Okay. So line staling is when you are leaving those whips, long branches with fruit at the end, and they are hanging. They are always hanging. So what happens with that? They snap in the wind. You are actually letting them snap in the wind. They can fall also, and they are exposed to the sun's scald also. So what is the weight distribution? That means these are the 2 things that you can actually do wrongly. And what is the improper pruning? The fruiting wood is distributed around the entire length, keeping the center of gravity close to the trunk. And in line staling, all the weight is at the end of the long whip, which acts like a lever and makes the branch prune to snap. So all the fruit should be very close to the trunk. Yeah, see, these were the problems that you could have encountered, like the flush cutting or the tail lining. Then in climate stressed orchard, the ability to wake up latent bud is a survival mechanism. So when we are cutting things, what we want? We want further growth, na? So what we are actually waking up? Latent buds. Okay. So latent buds are the survival. जैसे आपका high density है, high density में डच कर देते हैं. तो हमें कौन सी चीज बोल देती है कि डच कट में आप कट मार दो आपको नया ब्रांच निकलेगा? There's a physiology behind it. What is a latent bud? Latent bud is a dormant or adventitious bud. Are you able to see that latent bud? No, we cannot see the latent bud. Yes?
We are able to see its bulge only.
No, not even bulge. It is lying within that branch collar. It is sleeping. If you don't give a cut to that branch, it will remain sleepy. Why? Because that oxygen will not allow it to grow. Once you are removing that oxygen, it gives signal to that latent bud that you have to wake up. Now, in stub also you are doing the same thing. You are cutting it now. So you are also waking that bud. But why is it that latent bud is behaving differently in the Dutch cut and differently in the stub cut? There it is giving you it is giving enormous growth that we call that a water sprout.
Yes.
And why in Dutch cut you are getting a fruiting later? Right?
Yes.
So I will be telling the reason also. See, it's a tiny backup growing point that stayed behind when the original branch grew out. Okay. The hiding as a tree adds new layers of wood, rings each year, it grows over these buds. Okay. Now they stay alive just beneath the bark. You cannot see that, they are beneath the bark, connected to the tree's vascular system, and they are waiting for the signal to sprout. And what is the signal? That cut. Signal. When you perform a Dutch cut or a stub cut, you remove the hormone oxide that I was discussing, and they suddenly the tree sends sap to that area, and the latent buds they push through the bark. Okay, so both the cuts will do the same thing. They will push the bud through the bud. You are not able to see the latent bud. Yes, but you are able to see these vegetative buds, the floor, but not the latent buds. So what happens? I told you that why is it that when you give a Dutch cut and when you give this stub cut, the growth is different, right?
Yes, sir.
Yeah, the growth is different. That is called epicormic growth. Now what happens when a latent bud breaks through the bark, the new shoot is called the epicormic shoot. In your orchard, you will likely know these as water sprouts. So आपके पास जो orchards में water sprout है, that is the epicormic growth. If you cut too deep, that is the flush cut that I was earlier explaining, you are removing these buds and the tree loses its ability to ever grow a branch in that shoot again. Okay. Then
That's why हम recommend भी करते हैं ना कि हमें पूरा thin out tall spindle में कोई thin out branch करनी है.
Yes, correct. So we have the Dutch cut and the stub cut. Dutch cut when you need that desired epicormic growth. So epicormic growth is nothing but it is when the latent bud wakes up. But in Dutch cut you want a desired growth. So when you make a Dutch cut, you are intentionally waking up those latent buds. The result, because the cut is short, it is 1 to 2 inches and angle, the tree sends a moderate amount of sap to that spot. Because it is very small, so it gets a moderate amount of sap. Why we don't call it as water sprout? Even if it comes out, we don't call it a water sprout, we call it a fruiting branch. Why? Because we call it a replacement later. Because the cut is made at the base of the branch, the new shoot usually grow out horizontally. And when you talk about the water sprout, it goes straight up. Right? That goes up. But in the Dutch cut, you get a horizontal calm fruiting later. Because it is very small, it's a latent bud and it's very small. Then stub cut, that is the delayed or aggressive growth. With a longer stub cut, that is 3 to 6 inches, the behavior of the latent bud changes based on tree energy. Iska behavior, it will be decided by the energy of the tree. That is, it will be water sprout. If the tree is very vigorous, the latent bud at the base will explode because the stub is long. These shoots often grow straight up to compete for light. That is what we traditionally call as epicormic water sprout. So from the stub you can have water sprout, and from the stub you can also have, if a tree is older or under climate stress that is drought, the sap might not even reach the end of the 6-inch tap. So what will happen? The latent bud stay asleep because the tree is tri-aged. It is saving its energy for the fruit and not for making new shoot. So from the stub cut you can get a vegetative growth or you can get a direct water sprouts. But from the this Dutch cut you will always get again a fruiting. And sometimes what happens that Dutch cut will not respond the way this stub cut will also not respond the way we want to see. That those things, it can be due to some other factors, that can be nutritional factor or some other factors. Okay. See, now we have thinning, Dutchwood, stub and bending fruit, right?
Yes.
So what will happen? We are giving thinning at collar, then Dutchwood, bevel or angle. It is like this. If we have a branch like this, the upper tip will immediately remain attached to this trunk, and from this lower side it will be at an angle. It will leave the branch collar.
Yes.
It will be like a slice. And stub, we are leaving a firewall. It traps firefly bacteria so that it can protect further. It can protect us. Then bending fruit, that we know that we are putting the branches horizontal so that it can calm the tree. So now since we have entrepreneurs here also, so for entrepreneur, training is a fixed cost insurance policy. Like how? When you talk that you have to see, for entrepreneur what he wants to budget everything. He wants to have less water, so he wants to have lower water cost. He wants to lower the labor cost. He wants to risk. He wants to have get away from the risk. So when we talk about the lower water cost, that means an entrepreneur should understand about the LAI management, that is leaf area. Lower water cost by manage the leaf area index. Essentially removing the water, so what he can remove? The water sprout that act as hydraulic sinks. Pruning reduces the tree's overall transpiration rate, conserving soil moisture, pruning drought, right? Then lower the labor cost. This is that you are transitioning to the simplest base system like a tall spindle, where it is pedestrian friendly. What it means that while moving through the orchard, you can pluck everything, you harvest by hand. You don't need that raised ladders, and you don't need 2-3 laborers to pluck the fruit, which is easily, that's why we call that pedestrian friendly. While walking also you can manage your tree. And also when we say that we want to minimize the risk, that is structural pruning, that will prevent the loss of your tree. As you have earlier seen, when we have a heavy snow, lots of trees fell down. That means 10-year-old, 15-year-old, and that means a lot of investment. So for an entrepreneur, he has to manage, he wants to lower the water cost, he wants to lower the labor cost, and he wants to lower the risk factor. So all these things are very important for an entrepreneur to manage. So that means the standard operating procedure is the climate smart pruning protocol, cut for the future, not for the fruit. So see, the bottom line, the crop damage, he has a fixed crop insurance. That means he needs to have the net. Okay. So these are some safety things that you need to understand, that you have, these are the takeaway. One, whenever you are going for the pruning, you need to sterilize your tools between trees. You have to prevent the mechanical venturing of climate-driven pathogens. And rule is, if it is black and oozing, leave a 6-inch sacrificial stub. That is that I already talked about, the stub cut. That you are leaving a sacrificial, that even if dies, doesn't matter, the main tree will remain intact. That's the safety first scan. Then the big tree removal, the simplified step. Icon the balance, remove branches that break the resilience rule, that is too thick. Anything that is great, that you have already studied, anything that is greater than 50% of the trunk diameter, structural is risky, so you have to cut that. Then too low, anything below the knee height, you have to remove that, so that it can allow you for the airflow, the splash zone will be less. Too vertical, angry wood that steal water and shade the bottom. Okay, so you have to remove all, that is very vertical, the low and the too thick. So this is the balance, how you have to apply the big tree removal balance. The touch cut, again, it will increase the renewal process, so you have to renew 20% of the tree every year to keep the hydraulic pipes efficient. Then the anchor, that is the U shape, and delete the V shape. So if a branch has included bark, a tight V, remove it. And that means the U-shaped joint act as harmonic oscillators, they flex in windstorms. V joints, they act as wedges and separate the trunk. The dapple test. You know what dapple is? Dapple is, I told you about the light matrix. When you look at the bottom, you can see a few spots of sun, a few spots of shadow. So that is a dapple effect. So you have to create that. That's the sun step. So do not hollow out the center. What you have to do, you have to thin enough for air, but keep enough leaves to create the dapple shape. There should be a shape. So it will protect the trunk and fruit from UV necrosis and sun scalding during heat domes. Summer sucker removal, that's the water step. That means you have to remove the water sprouts. So that is how you can maintain your leaf area index, and it can save you up to 20% soil moisture from the actual fruit during jumps. So this pruning is like a technical, it's very technical. The more you try to understand it, the more you have lots of confusion in it. So I try to balance it, that how we have certain vagaries of nature and how our pruning can become a tool for that resilience. So if you have any questions, you can put forward your questions. I'll be happy to answer.
Why upright shoes are always rigorous?
Why?
Upright shoes are always rigorous.
Or?
Always rigorous.
Yes, because they pull to uptake the nutrients from the source is very high. Why? Because there is a continuous flow. Transpiration is, we can say transpiration necessary even. So leaves are there, they are continuously pulling, and the water molecules, they don't have any bending or anything like that, so that they have a straight column. So they are vigorously growing. But when we are keeping this as horizontal, we are breaking that column.
Yes.
So we are trying to calm it down. So certain things gets fixed in, and it's like a calming down. So that's why these water sprouts, they take up a lot of nutrients, and they are vegetatively, they are growing very vertically very high. So we have to do it.
Any other question?